Kelvin, you start.
Yeah. You start? Okay.
You started the whole thing.
Okay, cool. Yeah, so I guess I'm kind of just competing in this competition is kind of my brainchild. I took a class taught by Professor Jason Wren in the fall of this year, and in that class he exposed me to a lot of technology. It was entitled Resource Recovery for a Circular Economy. And so in that class we were basically just doing a very cursory overview of a lot of the technologies that one could use to recover resources. And one of the things that was mentioned and that Professor Wren has done previous work in is like microbial electrochemical technologies. And so I thought that was like the coolest thing ever when I heard about it. And being a civil environmental engineer, I was also taking a class about wastewater treatment. And I was seeing all the inefficiencies in wastewater treatment today, and then hearing about, microbial electrochemical technologies, I'm like, hey, that seems like a very natural fit. There's like a lot of stuff that can be done. So then I contacted these fellas, most of which are from our old high school robotics team, who had done competitions in the past, and Andrew, we joined in as our biochemist specialist, and we were like, hey, let's try to figure out how to implement this. How will we actually try to decarbonize wastewater treatment?
The feedback that we got from the judges was really useful and not just from the judges too, because the judges kind of inspired us to go out and then actually contacted industry leaders, people, from companies like Veolia, and then from academia, and on the business side of things, our business sort of mentor at St. Andrews, Bonnie Hacking. And so the feedback from the judges took our initial proposals to the next level, because it inspired us to go out and improve our ideas by checking out the different business models that we could use, doing the site visits and finding out how we could actually implement our technologies, both in terms of a long-term and short-term business model, which was something that we kind of were inspired to do after our conversations with some of our business mentors. And so that sort of iterative cycle, we started with a very sort of basic fundamental goals, and it really did just kind of bloom out into a more robust sort of project.
I think put a lot of pressure, like what Andrew said, to kind of like improve, right? There was a lot of pressure to improve and see how can we take this comment and then just take that
To the real world.
To the real world, and contact people and really try to push something that we theoretically had in our heads 9 months ago, maybe half baked, into something that now it seems like people have interest in. There's a lot of, seems to be interest in it. And that has been a very positive experience.
And I think we had an idea on the technology, but the judges, again, helped Tim and Andrew really spearheaded sort of the business side. They went and visited a wastewater treatment facility and really just boots on the ground, trying to figure out a business model, business plan, and really bring it, like you said, from our heads to the sort of real world.
I think some of us were a lot more familiar, Kelvin had a whole class on it sort of thing. Yeah. And I think some other people in our group are pretty familiar with it, but I personally didn't really have much experience with this idea of a circular economy. I feel like I've heard of a lot of products and projects where they do take things that are traditionally considered waste and reuse them and everything, but I think I just didn't recognize that was really a circular economy. And I think through this entire process, I've really been able to learn what goes into making something truly circular. It's not just about taking a project and making something that is sustainable, but it's about making it more circular so that all goes back to the beginning, and that it doesn't end up becoming a linearized system where waste is produced at the end.
Personally, for me, it's just, I find it really interesting being able to utilize a lot of waste materials. It always, it kind of bothers you that you see a lot of waste products coming out of maybe these sort of everyday things that we take for granted, like wastewater treatment, right? Or even food waste, compostables, plastic waste, all these sorts of things which we've grown up being shown, through school and through society. It's really kind of empowering and fun to be able to re-engineer solutions to those pre-existing problems. And quite frankly, the science behind it is all just extremely fascinating. So it's a nice intersection between real-world problems and applications of subjects that we really love. I think that's the most exciting part for us.
I definitely agree with that. I think it's something that all of us have kind of grown up with, is seeing this waste. We hear about all the microplastics in the ocean, the giant landfills everywhere, like huge amounts of waste, and areas where it just feels like, it seems like we're coming to a point where we really need to focus on sustainability and doing things in a greener way. So it's really, really awesome to be able to look into what it's like to actually do that, to make something action, and to be able to do that ourselves. So it is very empowering to be able to be part of that process, and to get a look into what it means to make things more sustainable, greener, and better for the environment.
I think there's a lot of value to be gained from like different perspectives on a problem. Like even like I guess one example of this that's not totally related is I hear from a lot of energy people, because I'm very interested in like the energy sector, about like ammonia and using ammonia as a storage mechanism for hydrogen. But then you talk to people in like atmospheric chemistry, which I took a class in this semester, and they're like, yeah, ammonia, if you had a leak of ammonia into the atmosphere, that would be detrimental. Like, so it's like what one person sees as a potential solution might have added adverse consequences that one might not initially consider. And so I think having a diversity of perspectives on the issue really lets you tackle the problem in a way that you trying to identify these like potential like adverse consequences before they happen, so that you can tackle them in advance, rather than putting the solution out and then dealing with all the adverse consequences after, which has kind of been the modus operandi of traditional business and work. Yeah,
I'd really agree with that. And I think particularly for our project as well, because microbial electrosynthesis has been something that's primarily been driven by environmental engineers and other engineering people like Kelvin and Professor Chen. I think it's been really interesting incorporating other sorts of interdisciplinary fields into it, because the way that Kelvin might look at a problem is very different from the way that Timothy or I, as biochemists, might look at a problem. And we have different solutions and different visions for how this sort of a system could work. And I think that kind of combining those visions ultimately enables us to have a much more robust and competitive technology.
It's just been really great to be able to connect with everyone and hear all the ideas that they have. I think it's definitely different from, we've seen all like the website and have seen all the other participants, but it's different to be able to talk to these people and to really interact and see what their perspectives are behind what they're doing. Like, why did they choose the certain things that they did? What sorts of like obstacles have they had to go through, and what sorts of advice might they have for us? So I think it's something where it's really nice to be able to have that interaction. And I think even just whenever we've been like sitting down, eating lunch together, we've had so many ideas just like pass around, iterating on designs and talking about problems. So that has honestly been a really great thing to have those conversations and really see how other people are also excited about making things more circular, more sustainable, and pushing us towards hopefully a greener future. So it's really awesome to be able to see that from other people who are also in a similar age group and everything.
Well, I think it's like incredibly inspiring to talk to, the rest of the teams. And although we come from like very different backgrounds and we're all working on extremely different projects, there is like a shared vision for our future. I think what's incredibly exciting about just soaking in, their projects and what they're working on, is that we're all kind of working towards the same goal, but just tackling it from very different perspectives.
I think the experience has been invaluable, like throughout this whole process of like developing our product and idea. And I think we touched on this earlier, but like forcing us to like think about it from different perspectives. And I think it also shows us a lot of like what we need to do if we want to like advance this project to, because it's easy to have like an idea and say, oh, this would be a great thing for someone to do. But then there's a lot that goes into taking an idea and then making something that is actually like a physical product that could be implemented. And so I think a lot of what this prize has like showed us is how to take those steps and like where those next steps are to realize this.